All right. Then the second speaker is the Mario Crucini at Vanderbilt. Hi, Mario. Are you there?
I was muted, excuse me. Yes, I'm here.
Okay. Hi, how are you?
I'm very good. How are you?
I'm fine, thank you. So can you share your slides, please?
Yes, thank you.
Okay, you have also 30 minutes, and I'll collect questions at the end and then ask. Please go ahead.
Is that large enough to be visible for everyone, I hope? Or maybe...
Yeah, I think it's okay for me.
Okay, thank you. So thanks everyone for joining this virtual conference. And I want to thank the organizers, David, Mick, Ippy, Janelle, and last but not least, Kwan Ho, for inviting our paper. This is joint with Moto Shintani and Takayuki Saruga, who are both here, I think, in the virtual room. I really appreciate their collaboration over the years. It's really improved my scholarship. So this paper is about the aggregate real exchange rate and also law of one price. Increasingly, research is putting micro data together with aggregate data. And we think, as many do, that it's important to reconcile the aggregate real exchange rate with LOP deviations. So we're taking one particular attack on this in this paper. So I don't think there's any need to remind people what the law of one price is or PPP, but just in terms of notation, we're going to have QIT be the law of one price deviation, and QT unsubscripted is the aggregate PPP measure. I'll show you some pictures in a second which have distributions of LOP as well as the aggregate real exchange rate, just to give you a sense on how these evolve relative to each other. The puzzles, there are, yes, many. I like to think of real exchange rate research as sort of like taking a raw piece of marble and chipping away at it for many years, and eventually David will be revealed. But we have some ways to go, perhaps. So going back to Rogoff's quote, which I think is still reasonably accurate, is that half-lives of deviations of PPP are just very persistent relative to what plausible lengths of nominal rigidities a la Calvo might imply. And then we have another puzzle which is relatively new, and that is law of one price deviations seem to decay more quickly, and LOP is more volatile than PPP. The volatility is maybe not quite so surprising since there's some averaging out of deviations, but the persistence tends to be lower in the data. So squaring the micro data and the macro data requires some considerable effort. This picture, we're going to focus on US-Canada bilateral exchange rates and micro data, but I think this exercise could be applied more generally. So the two lines here are the nominal and real exchange rate. So this is a familiar figure. The nominal and real exchange rate are very highly correlated over time, and they're both very persistent. If we look at the micro data for the same pair of countries, and this micro data is going to be from the Economist Intelligence Unit data. It's certainly not barcode scan level comparability, but it has some pretty good comparability across many of the items in the baskets. There are 274 lines in this picture. I don't expect you to see any individual one. I just want to convey with this picture that the median good, the median real exchange rate in the micro data, this red line, follows the aggregate CPI-based real exchange rate very closely. So in that sense, the average, the unweighted, if you equally weighted LOPs are pretty close to the CPI-based real exchange rate. Notice also, though, there's a lot of variation around that mean. Some LOPs are much more volatile than others. And there is a fairly high degree of collinearity among the LOP and the PPP, but it's certainly not perfect. Okay, so we want to make sure we can capture both of these features, some of the features of the data in these two data sets. And we'll come back to them in more detail after I go through the basic model. So research question is really, we're bringing a behavioral explanation a la Gabay into the PPP puzzle. So we're going to think about an attentiveness parameter in terms of some of the state variables, where M is the attentiveness level. M equal to 1 would be fully attentive, as in using the state variables in terms of their observed values. M less than 1 is going to be discounting the observed variation, being less attentive in terms of the state variables. We're going to introduce this property into an otherwise fairly standard microeconomic LOP Calvo time-dependent pricing model. And then we're going to use microdata to estimate this key parameter of the Gabay model in this setting, this M parameter. So I'm going to give you some of the key results in advance, just in case I go too long. I've got quite a few slides, or maybe I fall asleep or you do, depending on where you're located. So, and first, the key theoretical result is going to be our law of one price equation is given by that equation in the middle of the slide. The law of one price deviation for good I depends on its lag value, and lambda is the Calvo parameter. This new part here is the aggregate real exchange rates can enter directly when agents are less than fully attentive. So we got a convolution of the inattentiveness rate, if you will, 1 minus M, and the 1 minus the Calvo parameter times the aggregate real exchange rate. And then we have an aggregate shock and a micro shock. And I'll talk about them a little bit more later, but the aggregate shock, think of as the nominal exchange rate change. And the micro shock you can think about as a micro LOP productivity shock, or potentially a country-specific shock that affects the whole home basket. So this is sort of like a complementarity between LOP and aggregate real exchange rates. It's kind of reminiscent of some of the other complementarities in the pricing literature that are more based on real rigidities, like in Ball and Romer, Bergen and Feenstra, and Woodford, and there are other examples. But it's derived here in an alternative setting and mechanism. In terms of the empirical work, we're going to use this EIU data for the US and Canada, this large microsample, to estimate the inattentiveness parameter. This Q tilde here is going to be like a quasi-difference and nominal exchange rate adjusted LOP. I'll explain the reasons for that in a minute. But we're purging a lot of the common movement in the LOP by doing that transformation. And that leaves us with basically observables, LOP on the left-hand side, aggregate real exchange rate on the right-hand side, and a few controls as well. And then the slope parameter will be 1 minus the attentiveness parameter. Okay? Our estimation results show that M is in the range of 0.11 to 0.23. Remember, M equals 1 is full attentiveness, so we're a long way from that null hypothesis, which makes the theory empirically compelling as opposed to just a curiosity. So I'm going to go through the model of inattention in the way it's set up in this Calvo good level nominal exchange rate, real exchange rate model. And then I'll go through the derivation of the key estimating equations from that model. And then I'll provide some results from the microdata in more detail, and then a few robustness checks on the results. So the way the simple model of inattention works is by thinking about a profit maximizing firm. We're going to approximate it here to the second order. And if you thought about this in general without any costs of optimization or any inattention, we're basically going to set the price each time we get to reset the price. Remember this Calvo pricing here, equal to the profit maximizing optimal price in terms of a forward-looking firm. Okay, so that's that's kind of the benchmark in terms of the rational or fully attentive agent. For the behavioral agent, if you will, or the inattentive agents, that objective function, and again, this is based on Gabay's approach, the objective function is modified with this parameter M, okay? which is going to be controlling the deviations from the optimum relative to the full attention case. Okay, so M is going to be endogenized in a minute based on a cost-benefit comparison, but we're solving this alternative problem for that case where M, again, is not restricted to equal to 1 as in the first case. Okay, so now the price is going to adjust towards the optimum price change, but less than fully. Okay, so M being strictly less than 1, think of this as sort of like a partial adjustment model, if you will, based on the endogenous choice that's constrained by this attentiveness behavior, or this inattentiveness behavior. So the way to think about this, the endogenous choice of M, think about the profit function in terms of the price change you're choosing relative to the optimal price change. And then we're adding this cost of attention, if you will. In Gabay and much of the literature, this is viewed as a psychic cost. There aren't going to be any real resource implications of this cost. And it's parameterized as C of M. So the trade-off in this maximization problem is the benefit of reducing the distortion to optimal price setting relative to the optimal level of profits under full attention, and the cost of paying attention, this C of M function. Okay, now the model, apart from the inattention, is going to be otherwise kind of boilerplate from existing papers back to Kehoe and Middelgren, and then extensions by myself, Moto and Taka. Quasi-linear utility, complete markets, and the households will be fully rational agents. Okay, so the household side is completely standard. The government is going to choose to control the money supply, and via cash and advance constraint and complete markets, that's going to determine the nominal exchange rate, one of our state variables. The firms are price setting monopolistic competitors. We're going to have local currency pricing. Calvo pricing with a probability of non-adjustment of lambda here, a linear production technology in the good eye with potentially, well, the default is going to be good specific productivity with a labor input. And Z is indexing the varieties of good eye. A trade is subject to iceberg costs, which creates an asymmetry at the good level because individuals consume different varieties of the of the goods in home informed countries. Okay. Under complete attention, this is the forward-looking profit maximization. This is the price adjustment for the home country, say the US, and in the home market, and the price adjustment for the USA in the foreign. So the mu is going to be the aggregate, we call the aggregate component of real marginal costs, which is basically the nominal wage and inflation. And the AIT is the productivity of the firm, which is subtracted since productivity increases reduce marginal cost. So again, the first one, the unstarred one, is the US market goods and the produced goods, and the starred one is the Canadian market. And then for Canada, for Canadian domestic producers and Canadian sellers into the US market, those are analogously defined or symmetrically defined. Within complete attention, we're going to use the notation where we index the optimal price change with this MH notation, the inattention parameter. Those can potentially be different across home and foreign price setting. We'll add some symmetry later on. So you can see the way we're building this in is we're having this inattention impact the aggregative state variable, the aggregate component marginal cost, and not the firm specific productivity component. So that asymmetry is going to be an important feature of our model. So you can think of essentially the M attached to the productivity variable as being a 1, meaning the firm is fully attentive to their own productivity when making their pricing decisions. Excuse me. So under the Calvo pricing adjustment, the home relative price of good eye is going to be a weighted average of predetermined local currency sticky price index and a reset price. So the Calvo stickiness is sort of standard in this part, And then the second part here, remember, is going to be basically a weighted average of the home and foreign varieties based on adjusting firms' prices. Okay, so those are the adjusting firms, and the adjustment of the goods price index is going to be a weighted average of the varieties from at home and imported based on the expenditure weights, which will be home biased in general based on trade costs. Okay, so beer is going to have a different price in the US and Canada because we consume different compositions of US and Canadian beer, and the real nominal exchange rate is going to affect that relative price across countries. There are going to be two types of shocks: money growth shocks and productivity shocks. So a home growth shock to money, which is going to generate a nominal exchange rate shock of the same proportion in this model. A foreign money growth shock, a home productivity shock, and a foreign productivity shock. The productivity shock is goods specific. That means all beer producers in the US face the same productivity shock, as do all beer producers in Canada. But beer producers in the two countries would face different shocks. Okay, so what about the LOP implications? The first proposition, one of the key propositions of the paper, is that under the assumptions of this Calvo time-dependent pricing model with the inattention augmented to it, the law of one price is going to follow a first-order autocorrelated process with parameter lambda. So that arises in the fully attentive model as well. You can see that by setting m equal to 1, and then the second term drops out. And we're back into the more standard Kehoe-Midrigan type of specification. So the aggregate real exchange rate appears now analytically in the LOP equation, and its weight depends on this inattentiveness parameter 1 minus m. And then again, the two shocks are the nominal exchange rate with that factor Calvo loading lambda, and then the real shock is weighted basically by a shock that depends on, a parameter that depends on the trade frictions and the elasticity of substitution across varieties, obviously. The nominal shock is going to be IID for the change in the nominal exchange rate. The real shock will also be IID, although we'll look at robustness to other parameterizations of the productivity shock. So the key takeaway here from this key first proposition is that there is a direct analytical relationship between the LOP and the aggregate real exchange rate when there's less than complete attentiveness in the sense of Gabet for the aggregate state variable. The way we're going to test this is by using the microdata in a number of ways. Some will be a little more restrictive than others. So if we rearrange that I'll call it it's a structural equation. So if we rearrange that structural equation, we can isolate what we'll call a quasi-difference nominal exchange rate, shock-adjusted exchange rate, i.e. take the law of one price minus the Calvo parameter and the lagged law of one price deviation, subtract the nominal exchange rate shock, that's the left-hand variable, and then we can regress that on this right-hand variable, which is just an adjustment to the aggregate real exchange rate, where the adjustment is 1 minus the Calvo parameter. So notice that the left-hand side now is all observable variables based on the model. The LOP, Calvo parameter is going to be parameterized. That's what I mean by observable there. And then the nominal exchange rate is going to be the change that determines epsilon NT, this adjustment right here. And then the right-hand side will be, again, Calvo parameter 1 minus the Calvo parameter times the aggregate real exchange rate. Okay. So just to write this more compactly, these tildes are these adjusted variables, and then we'll have a few controls. We're going to use the EIU data, a subset US and Canadian cities, 68 bilateral city pairs in this data set, 274 goods, and 26 years of observations. This again is the picture that I showed you at the beginning. So again, we're using each of these lines as a data series to estimate the M parameter. And in our benchmark, remember, we're assuming in this benchmark that the lambda is the same across goods. There's evidence that there's some differences in price adjustment frequencies, and we'll incorporate that in robustness check in a moment. So you can see here that beta, the slope coefficient on the aggregate real exchange rate, is about 0.8 to 0.85. If we translate that into the attentiveness parameter, which is 1 minus beta hat, we're in the neighborhood of about 0.16 to 0.2. Recall that the null is 1 for full attentiveness, so we're clearly a long way from the null hypothesis of complete attentiveness to the aggregate state variable given this microdata. We've done robustness for country-specific productivity shocks. So remember what this means. We would then allow the entire distribution of productivity in the US to change relative to Canada. That affects the controls a little bit in the specification and also affects the estimation method. But the results are very robust to this. M is still 0.15 to about 0.2. The last robustness check is, as you might expect, it's important to take into account different rates of adjustment in the LOP. So now our quasi-differenced data is based on good specific lambda parameters, and we weight the nominal exchange rate by the good specific Calvo parameter. So that's all based on the null hypothesis of the Calvo pricing model. And then we have to do the same thing for the real exchange rate on the right-hand side. These betas are a little bit different from the common lambda parameters, but they're still quite high. And again, we reject 1 for complete attentiveness, and we end up with a range of about 0.13 to 0.2 in this case. This is robust to the inclusion of goods fixed effects and country-city pair fixed effects in 390 million observations. So just in terms of summary of the estimation, we reject strongly the null hypothesis of full attention. We therefore find strong evidence of behavioral inattention. And this is not just econometrically significant, it's economically significant. The attention parameter is well below 1 in the neighborhood of 0.1 to 0.25. So I want to circle back now to review the implications from LOP and PPP deviations based on things we typically look at in data. So there's a second proposition, which is just to state what might be hopefully a bit clear at this point, that in this inattentiveness model, the aggregate real exchange rate persistence is bound strictly above the Calvo parameter in this model, meaning that if you have full attentiveness, you revert back to the Keogh-Midrigan or our previous kind of Calvo benchmark models, where Calvo determines persistence one-for-one in the microdata and in the macrodata. With inattentiveness, you elevate the persistence level. And how much you elevate it depends on Calvo and the inattentiveness parameter based on this equation down here. That's an analytical result. Graphically, it would look like this. If you had complete attentiveness, m equal to 1, you're back in the fully rational attentive model. The persistence equals the median Calvo parameter of 0.37, say 3.4. As you move to less and less attentive firms, you move towards a persistence of 1, which is the persistence of the aggregate state variable. And remember, our estimates are somewhere in this range, which is a significant elevation over the Calvo benchmark model. At the LOP level, we can also look at the second part of the puzzle, which is LOP has less persistence than PPP. That will also hold in this data as a result of inattentiveness. So we're all going to also bound the persistence of the aggregate exchange rate above the LOP deviation. That's what this equation is showing. This will depend on inattentiveness, of course, but it also depends on the ratio of real to nominal shocks, which is this A parameter and a few other parameters here. So graphically, at the endpoints, LOP and PPP have the same persistence, but in between, we can get LOP persistence to be strictly below the aggregate real exchange rate, and oftentimes considerably in terms of this distance. Okay. So in terms of implementing the estimates we had, we can look at those graphs in terms of more empirically informed range to examine. If we look at m equals 1, fully attentive, we have the PPP puzzle. Persistence is too low to explain the 3 to 5 year half-lives. LOP, persistence is equal to PPP, and again, that's even farther from the data. If we move to 0.23, we're getting closer to resolving both the PPP and LOP puzzles. If we move up to 0.17, which is towards the lower end of our estimates, we can get close to resolving both the LOP puzzle, so our half-lives are about a year, kind of on the lower range of the data here, and our, excuse me, our PPP half-lives are about 2 years. And then if we go even farther to 0.11, which is at the left-hand boundary of our point estimate ranges, then we're kind of almost in the middle of both of these aggregate and LOP ranges. Okay, so I don't know, maybe I went too fast there, but I think I've finished.
Okay, Mario. Thank you very much. Do you hear me, Mario?
Yes, I do. Thank
Okay.
you.
So I have few questions for you.
Okay.
Ipei has one question. His question is about the possibility mechanism other than inattentiveness. Is there any way to change the impacts from the aggregate real exchange rate on the individual real exchange rate? So his question is if there are any other possible candidates that such as the adjustment costs, learning, or etc. And my question is also similar to his. Your estimate of N is surprisingly low to me, and I'm wondering if there is a. I'm wondering whether that kind of attention cost is that costly. I mean, to get information on the aggregate marginal cost, is that costly? And I have two more questions by Genial. His question is whether you have chance to look at the MITs across cross section or time series. He would like to know whether the distribution matches our prior knowledge. And he's also one more, but I can see that yet. So would you like to answer the questions so far?
Yeah, sure.
Yeah.
So the first question is, are there other mechanisms that would generate this kind of common factor, I guess, between the micro law of one price and the aggregate? And there are a large number of such mechanisms. So this is not meant to displace any others. So for example, non-traded goods, which have a role in many retail prices, would be a common factor that would generate some collinearity between the aggregate real exchange rate and LOP that is not in our model, for example, because we have just traded goods. The learning, I guess, an alternative interpretation is to think about this M parameter as, grounded in terms of a signal extraction problem. So if the if the noise to signal ratio is high, you discount information in your price setting possibly. So certainly there are other ways to cast the motivation for either using less than full information or discounting information that you have based on your decision rules. So I think those are all plausible alternatives. I guess the aggregate, when we think about the aggregate shock, I think our models point fairly directly as to what those might be, but I think in reality it might be a bit more obscure to some firms that are functioning in individual markets, what the direct relevance is of the aggregate CPI or the aggregate wages for their pricing decisions. Now, our model might not be rich enough to elucidate all of those because it might need deviations of wages across firms as well as productivity. But I think they're non-trivial. They're non-trivial inference problems at the firm level in terms of knowing what the aggregate states are that are relevant for them in real time, especially. We've also thought about maybe adding a bit more symmetry to the micro and macro shocks in terms of the inattentiveness. That's another way to get to your question. I didn't get the NIT. I don't think I followed the NIT. Ipe, was that your question in terms of the cross section? I missed the notational reference and what exactly that was referring to. NIT in the cross section. What was that referring to?
He's asking MIT. MIT. I'm not sure what that is.
We have an epsilon IT in terms of the productivity shocks at the firm level. If you want to put your mic on and clarify, or if you have time.
Yeah, maybe I'll ask him later.
Okay.
So, hi, this is Janelle. So I like to know, you estimated M's, different inattention parameters.
Yes.
So they should,
M.
MIT, sorry, yeah, MIT. So they should differ across different goods. So whether people are more attentive for beer versus wine versus apples or whatever. Yeah, that's my, so whether, because at the level, I understand people's concern about whether it captures correctly or not, but also the cross-section wise for different goods, whether they have captured correctly ordered according to our prior.
Okay, thank you. Yeah, I understand that. So yeah, I think, given we have a time series, we could certainly look at good specific MIs, I guess. The M here, remember, is the firm's attention to an aggregate variable, which is maybe a little different than what you're thinking about in terms of consumers purchasing individual goods based on their attentiveness. Consumers are fully attentive here, but I think we could explore that cross-sectional aspect that you're referring to as well. Thank you.
Okay, I have the one question by Mick, and his question is whether you can tell us a story about this to give an intuition. And Andy Giraldo has another question about if the capital A's are moving over time. The Canadian exchange rate seems to be disproportionately influenced by the price of oil. Would the sensitivity of Canadian dollar to oil price relative to the US dollar, which is not taken into account in your model?
Yes, I mean, the story has to be something like instead of relying only on the sticky price, not responding to the nominal exchange rate and aggregate state variable, that there's an underlying inference problem that's costly, which is what originates the M parameter here. So it's adding a bit more micro foundations to why firms don't respond to the aggregate state in the model. And that kind of takes some of the pressure off the Calvo parameter in terms of explaining all of the persistence. The nominal to real exchange, the nominal to real shock variance is a parameter in that for the LOP deviations, of course, since the real shocks are presumed to be partly good specific. The oil price, I would say, I would probably introduce that in terms of a covariance with maybe the aggregate state variable. And then we'd have to think about how to parse the covariance between oil prices and other macro variables in Canada in order to do that decomposition more carefully. So our controls are attempting to do that because we have labor productivity for the US and Canada, but we certainly didn't include oil prices in that control vector. So that's what we would have to do to help take care of that type of issue, or possibly maybe use oil sensitive relative to oil insensitive products in the basket maybe would be another way to get a handle on that.
Okay, final question is by David Cook. He's asking how much of this is driven by heterogeneity in Calvo parameters. If all pairs had the same lambda, would aggregate matter? That's the question.
Yeah, so I think that might be revealed when I went through the case where we estimated the Calvo specific versus the common Calvo, we get the same M parameter. Now, obviously, when you look at the cases with Calvo specific parameters, those LOPs do have unique autocorrelation properties based on the Calvo parameter. So they are dynamically evolving differently than in the case of a common Calvo parameter. Like anything else, there's some central tendency to persistence across goods, and there's some central tendency to the Calvo parameter across goods. So you can view it either as the Calvo parameters are, noisy estimates of a central tendency, or there's unique differences. Obviously, food and energy are frequently changing, and I wouldn't want to compare them to services in terms of their dynamics or the shocks. So I think we have the heterogeneity embedded in the estimation of M, but again, in one case, those are collinear in terms of the dynamic impulse responses given lambda is common. In the other one, they have somewhat unique persistence properties with the lambda i's being different. I hope that answers your question.
Okay, thank you, Mario, again. And I'd like to close the session 1 now. I'd like to thank everybody, especially presenters, at very late time in your time zone. We'll meet again in 10 minutes with keynote speech by Felipe Baghetti. Okay, so let's have break for 10 minutes.
Thank you.